Hi guys, thank you so much for watching my sessions on Crack Easy, the place to learn how to crack easy exams. Recently, as I was going through the comments on my post, one of you have made a request to do sessions on signals and system. So, I think it's time to start doing videos on one of the most important subject from competitive exam point of view, which is none another than signals and system. First of all, let me share some tips to perform better in this subject. Signals and system is basically a problematic subject, so you should practice maximum number of problems on each topic. Then only you will understand how to solve different types of problems within short time. Apart from that, it is better to form a formula list and stick it on a wall or board and keep revising so that when you see a problem, you don't have any confusion in the formula to be used. Finally, if you want to solve problems without making mistakes on a particular topic from signals and system, you should have a clear concept of that topic. So when you prepare a topic, it is better to make a clear concept first, then start solving problems. Alright? Today, I'm here with a video which shares all basic concepts of signals and system. As I said to you earlier, it's a problematic paper. So if you want to perform better in this subject, you should have a clear concept of all the basics. So please do watch the lesson completely. Here we go. Let us first understand the concept of signal. I think most of you are already aware of what is a signal. Can anybody give me a definition for signal? How can we define a signal? Alright, a signal can be defined as a physical quantity that varies with the time, space, or any other independent variable. You can see a word independent variable here. Do you know what is it? Okay, let me explain. Basically, we have two types of variables, independent variable and dependent variable. As the name indicates, value of a variable always changes. Independent variables are the variables where the variation doesn't depend on any other variables, which means either we have to change it or it changes its own. On the other hand, the value of a dependent variable varies with respect to another variable. Got it? If you don't understand it right now, don't worry. I will give you more examples to get a clear picture of what is a dependent variable and what is independent variable. Suppose we are measuring pressure with respect to altitude. So here we have two variables, pressure and altitude. Now, can you identify the dependent and independent variables here? It is clear that altitude is the independent variable because it changes its own. On the other hand, pressure is a dependent variable which varies with respect to another variable, altitude. Got it? I'll give you one more example. In this experiment, we are measuring temperature with respect to time. So, temperature and time are the two variables here. I think you can easily identify the independent variable here. It's nothing, time. And temperature is the dependent variable which varies with respect to another variable, time. Hope you got a clear picture of what is dependent variable, what is independent variable. Let us now come back to signals. It's a physical quantity that varies with the time, space, or any other independent variable. Now, I will give you some examples of signals. You can see a network here. Vs is the source voltage and Vc is marked as voltage across this capacitor C. As time changes, the value of source voltage Vs changes. Correspondingly, the value of capacitor voltage Vc changes. Hence, we can consider these two voltages Vs and Vc as signals whose values changes with respect to time. I'll give one more example. Consider the human vocal system. It produces speech by creating fluctuations in atmospheric pressure. Hence, speech can be mathematically considered as variation of acoustic pressure with respect to time. Or we can say that it's a signal. Let me now take you to a classification of signals based on number of independent variables. As I told you earlier, signal is a physical quantity that varies with respect to independent variables. Based on the number of independent variables, we have one-dimensional signals and two-dimensional signals. In one-dimensional signals, the value of the signal depends only on one independent variable. Speech and variation of room temperature with respect to time are examples of one-dimensional signals. In speech, the acoustic pressure is varying with respect to time. Hence, we have only one independent variable, time. Thus, it's a one-dimensional signal. On the other hand, in two-dimensional signals, the value of the signal varies with respect to two independent variables. Image is an example of two-dimensional signals. Consider the black and white image. It can be mathematically considered as the variation of brightness or intensity with respect to two spatial coordinates x and y. At each spatial coordinate xy, an intensity or brightness value is assigned. Thus, here we have two independent variables that are two spatial coordinates x and y. Let me now take you to next classification of signals. They are continuous time signals, discrete time signals, and digital signals. Let us first understand what is continuous time signals. In continuous time signals, the signal is defined for all values of independent variable. So, the independent variable here is continuous in nature. Most of the signals in real world are continuous time signals. It is also known as analog signals, which is represented by x of t. Speech and variation of atmospheric pressure as a function of altitude are examples of continuous time signals. Now have a look at the waveform of signal x of t. What we are going to do is we are going to check whether x of t is a continuous time signal or not. Variation of temperature with respect to time is defined as signal x of t. The independent variable time is plotted along x-axis and dependent variable temperature along y-axis. By scrutinizing this waveform, it is clear that for all values of time t, temperature value is defined. Or we can say that it's a continuous time signal. You can see one more continuous time signal x1 of t here. For all values of t, the signal amplitude is defined. Let me now take you to next type, discrete time signals. In discrete time signals, the signal is defined only at discrete instance of time, which means the independent variable here is not continuous, it's discrete. It is represented by x of n. Basically, we have two types of discrete time signals. In first type, the independent variable is inherently discrete, and in the second type is obtained by sampling a continuous time signal. I will explain these two types with examples so that you will get a more clear picture. In first type, the independent variable is inherently discrete. Consider this waveform. It represents the amount deposited in every month in savings account. Along x-axis is the month, that is another form of time, and along y-axis the amount deposited. Now look at this point. Is there any value assigned for this point of time axis? No. What about this? Here it is defined as 1000. What about this? No. Thus, the signal is defined only at discrete instance of time. That is why it is known as a discrete time signal. In second type, discrete time signals are obtained by sampling a continuous time signal. Do you know what is sampling? Okay, let me explain. In fact, sampling is a broad topic. Now, I will give you only a brief idea of sampling. Basically, sampling converts a message into a sequence of numbers, each number representing the magnitude of the message at a particular time instant. A switch can be considered as a simple sampler if we connect the message to input of the switch and the switch is controlled in such a way that it is closed only at time instant 0, ts, 2 ts, then its output will be sampled version of input message. Do you want to know more about it? Okay, now have a look at this continuous time signal. What we are going to do is we are going to connect this continuous time signal into the input of a switch which is operated in such a way that it is closed only at time instant 0, ts, 2 ts, etc. At time instant t equal to 0, what will be the output of the switch? At t equal to 0, the switch is closed and hence the output will be input itself, that is the message. What about ts by 2? At time instant ts by 2, the switch is open and hence the output will be 0. And for all time instants from 0 to ts, the switch is kept open, correspondingly we get an output 0. But at t equal to ts, switch is closed and the output will be value of the input message at t equal to ts. So when we apply a continuous time signal x of t into the input of a switch, the output will be like this. You can see it is defined only at discrete time instants. Got it? Finally, we have digital signals where the amplitude and time are discrete. For example, consider an experiment where we are measuring temperature with respect to time. If we are taking the temperature measurement continuously, then we will get a continuous time signal. On the other hand, if we are taking measurements only at a regular time intervals, we will get a discrete time signal. Suppose we are using a digital thermometer with 2 digits. Then the result will be a digital signal where the signal value and time can take only discrete set of values. Alright, so we are at the end of this session. If you have any doubts, please do let me know in the comment section. Thanks for watching. Thank you.